يلا بلش. Okay, so we speak today about lecture 7 and 6 of the logic circuit. We speak about the arithmetic circuit and the simplification of logic circuits. At the beginning, if we can think what is logic circuits and how we build logic circuits and what's the application of logic circuits. We studied in a previous lecture the logic gates. True?
Yes.
Okay. What is the logic gates? Who can explain some of them?
Not, and, or, NAND,
X or X and. So why we use it? Why we use the logic gates? To create the logic circuit or to build the logic circuit. What is logic circuit? It's the circuit we use it to make addition, subtraction, multiplications. Okay? So we use the logic gate to create a logic circuit. The logic circuit, we use it inside our CPU, our microprocessor, our computer to perform operations such as addition, subtraction, multiplication, as we mentioned before, okay? But what is the applications of logic circuits? What is the application of it? Where we can use the logic circuits? We can use it in signal processing, يعني معالجة الإشارة, data routing, control system, and microprocessor design. When we design the microprocessor, okay, we use it as a circuit inside it. We speak about the hardware of the computer, the main or the foundation parts of the creation of computers, okay? So, what is logic circuit? How we create it? By what? By logic? Gate. By logic gate we create it. And we can mention this is 4 of the application of logic circuits. Okay? We have 2 types of logic circuits, the combinational one and the sequential one. We speak previously about it, and the combinational one, the output depends only on the current inputs. The input we use it now, as we mentioned, X and Y and B is the input. It's not connected to the previous inputs, like when we have carry in addition. Okay? So, who care about it or who can use it? The sequential. It depends on both the current inputs and the past input. What is the past inputs? If we make any addition, like 0, 1, 0, 1, 1, okay? We add it to 1, 1, 1, 0, 0. So, when we make addition, 0 plus 1, 1, yeah. 1 plus 1, 0, and we carry 1. Here, he cannot handle it. Why? Because we have a previous what? Previous inputs. It's the carry. We can only add a single input. Okay? We will see it through the other examples and subtractor. So what's the basic logic gates? Who can mention some of the basic logic gates? Hussam?
NOT gate, NAND gate.
Or XOR or X and, we explain it all, okay?
Yes.
And we know the logic gate, how we draw it, and what the truth table of each one of them. What about the arithmetic circuits? If we speak about arithmetic or math or arithmetic logic units, it's a unit inside the computer, inside the CPU. It's responsible about what? Arithmetic operation. What is arithmetic operation? Addition, subtraction, multiplication, division. صح? So, we will start about the key component of the arithmetic circuit. What is the key component? We will speak first about adder. We have 2 types of adder. Yes. Half adder and full adder. Okay? What is half adder? Half adder and full adder. What's the difference of them? Both of them are combinational logic circuits, but there is a binary difference between them, that the half adder only adds the current inputs. It's not care about the previous input or the carry input, okay? So it's only taking concern or depend on the current inputs. Okay? So as we explained, the half adder, it's designed by AND and XOR gates, and the half adder consists of 2 input terminal and creates 1 output. 1 output as the sum. As the sum. So the summation of A and B will have a result of sum here. It's the result or the output of XOR. And the carry, where it go? By the AND gate, the carry out. Okay, so this is the logic circuit of what? Of adder, of half adder. What about the full adder? This is the truth table of half adder, as we mentioned, the sum and the carry of the outputs. Okay, what about the full adder? What's the difference between them? Full adder, he take the carry in. What's the meaning of carry in? The carry in, this value, he take it in consideration. He can add it with A and B value. So this is the main difference between them. But both of them, they add. And we have also 2 outputs. The sum, it's the summation of A, B, and C in the carry in. And the carry out, it's what the carry out? Who can know what the carry outs? For any addition operation. What is the carry out and carry in? آخر carry. يعني which means the last carry out of the operation. We save it here by the carry out. Sorry. So this is the logic circuits of what? Of the full adder. Full adder. This is how we create a full adder. Yani if we are at a lab and we have the XOR and the AND gates and a switch to create inputs, 2 inputs and 1 CN, which means 3 inputs, we can create the full adder by connect 2 XOR and 2 AND and 1 OR. I think you remember I give you homework from the previous lecture. We ask about if we use 2 AND and 1 OR. You remember that?
Yes.
Who do it? We will get through it. Just in this slide, we will mention the full adder truth table. 3 inputs, 2 outputs. We have a carry out output, okay? So, full adder and half adder. Why we use full adder and why we use half adder? What do you think? If I have a single input, يعني just 1 input for A and 1 input for B, we can use full adder or half adder? Half adder is useful for that. يعني we can use it. But if we have a full series adder operation, like this example, we need to use the full adder because we have a carry in inputs and at the end we have a carry out. So we need to use what?
Full adder.
The full adder. Okay? So now we understand what the difference between both of them? Half adder and full adder. And what it do? What the main concept of adder? It's add or it's subtract or it's make a multiplication. From its name, what it make? Adder. So it's make what? Addition. صح? We add a bit with each others. Okay? What about the subtraction? We have also the main concept. What is the main concept? It's a logic circuit. We create it by logic gate. Why we created? To make the subtraction where? In arithmetic logic units. How we subtract 2 number? Yani if we want to subtract 2 number, like the same example, we can make subtraction. صح? Okay. So we use what? We use the subtraction logic circuits. Okay? And also we create it by logic gate, the simple logic gate. We have 2. Half subtractor and what? Full subtractor. What's the half subtractor? It uses one input or two inputs? 2-bit inputs, A and B. And the output will be the subtraction and borrow in. Borrow in, not a borrow out. But if I have, and this is what? This is the logic circuit of the half subtractor we created by XOR. And what this? This is AND or? And this is? This is not. Okay. What about the full subtractor? What's the difference between full subtractor and full adder? It's the same difference between full adder and half adder. The main difference is we use a borrow in from the previous operation as an input. Yani if we borrow from, if we make here 0 minus 1, 0 minus 1, we cannot. So we borrow from the previous one. This is borrow in. This is borrow in. We use it at the second operation as an input. So we have B in. Now in full subtraction, it's the inputs. Okay? It's the input for the next operation. And how we created? We created by this logic circuit. We say 3 XOR. صح? This is the sample of XOR. This is D. We create D by 2 XOR. And this is what? B out, borrow out. We created by make a notes for A and B in. And we make what? Or gate between the 3 parts or 3 section of the borrow outs. And we can mention also the truth table of full subtractor here. It's all information. We already take it separated in many lectures before. But now, if we can mention the half and full subtractor summary, the half subtractor is what? Is suitable for a single bit subtraction because it cannot depend on the previous borrow-in. But the half subtractor, the full subtractor, sorry, it handles subtraction involving what? Yeah, the previous borrow, which means the borrow-in. We take it as an input, okay, for the full subtractor. Okay, so now we finish subtractor and adder. Both of them the same concept. They have 2 types, the full and the half. Okay, what about multiplexer? What is multiplexer? Multiplexer, just focus on it. It's a digital circuit that selects one input signal from multiple input signal. Yani, it's a logic circuit. We name it max multiplexer. We take many inputs from I0 to I5, but as an output, we take only one output. Just one output. So it's a device we need it. Sometimes when we create any program, we need to choose, to select. Even now at a class, if I want any one of the students to answer me, I will select one of the students. The multiplexer do the same option. What it select? Select one output from many input we have it. Okay? So this is the option of multiplexer. What's the key component of multiplexer? We say multiple data line inputs. Multiple data inputs and control line. What's the meaning of control line? يعني how multiplexer can decide. Multiplexer, it have many inputs, صح? يعني here we have how many inputs? 5 inputs, صح? And 1 output. How multiplexer can decide which one of them we will take it as outputs? By 2 line. We say it's control line. مثلا S0 and S1. When يعني we can make it as a truth table, okay? So as a truth table, I will say if we have C0, S0 and S1, okay? And here's the output. How many inputs I have? 1, 2, let's make it until 3. 4 outputs. So we have, because we have 2 selection line, and you will see how. 0, 1, 0, 1, 0, 0, 1, 1. Okay? So we have 4 options. I teach it, I program it. If S0 is 0 and S1 is 0, the output will be I0. If S0 it's 1, the output will be I1. You understand me? I will select that. If it's 0, 1, it will be I2 and then it will be I3. So multiplexer, when multiplexer take I1 as the outputs, when the control line is 0, 0, both of them. You understand what the option of multiplexer? We take one output from several inputs, okay? So how it works? It's the same concept, I just mentioned it. If S0 and S1 is 0, 0, output will be I0 or I1. But we can change it. It depends on you. If you want, when it's 0, 0, we can take out مثلا I3 and here I0. It depends on you. يعني it's not a rules. خلاص. It depends on you. Whatever you choose at the selection line or control line, it will be the answer. Okay? So we have many types of multiplexer. The first type is 2-to-1 multiplexer. What's the meaning of 2-to-1? Just focus with me, please. What's the meaning of 2-to-1 multiplexer? 2, that means 2 inputs, and 1, what it means? 1 output. So from 2 inputs, we will decide to take 1 output. Okay? So this is the logic expression or instruction for it, and this is the control line. So if the control line of the multiplexer 0, the output will be the value of I0. If it's 1, the value of output will be what? I1. Okay? It depends on S. What is S? Is the control line of the multiplexer. Okay? The other type of multiplexer, 4-to-1. What's the meaning 4-to-1? 4 inputs to take 1 output. But can I create 4-to-1 multiplexer same like this one? It's 4-to-1, okay? Can I create it by use only 1 control line? يعني if I have only S0, it have only 1 option, 0, and the other option is 1. So I can choose only I0 or I1, but I have 4 options. I have also I2 and I3. So I cannot use one control line. I must use 2 control line. Okay, it's a must. So we add S1, 0, 0, 0, 1, 0, 0, 1, 1. Now we can create a 4-to-1 multiplexer by using 2 control line. Okay? The same, this is the option. So look at this. When 0, 0, when we complement, what the outputs? I0 or I1, it depends on you. يعني it depends on what you choose. It's not a rules, okay? But if I need to take one of the inputs, I must what? I must use the selection line or the control line, okay? It makes the decision for me. What's the application? Why I do multiplexer? Why I create the multiplexer? Why I make myself busy at lab to put a multiplexer inside computer or inside any CPU? Because we must use it for data routing. What's the meaning of data routing? Any program or any application you want it to choose one of many, you must use multiplexer. We have many applications in our life. We need to choose one from many inputs, okay? Communication system or arithmetic circuits or memory selection. We have many memory location and we need to select one to store our results, okay? Or digital signal processing. What's the meaning of digital signal processing? يعني at a traffic light, outside in Europe country, in USA, in Canada, if they make a sensor, they put a sensor at the street, okay? So if it's busy or crowded in street number 1, they will make the green line open for a longer time. You understand me? Yes. But if the other street 2, it's not busy, no need to make the light green at all until we have a crowded car or minimum 4 to 10 car, it depends on the country. So we open the green line. So it's signal processing or not signal processing. We choose one of the signals. Let's do it green line, red line, or yellow line, depending on what? Depending on the value of sensor, we use it at the street. Okay? So this is the application of multiplexer. We choose from many levels, many inputs. Like in deep learning approach, we choose from many levels or layers of deep learning, one option depending on the data classification, as you will see inshallah in arithmetic and AI subjects. So demultiplexer. We speak about multiplexer and now demultiplexer. It's the opposite of multiplexer. It's a digital circuit that can take single inputs to what? And distribute it into one of the multiple output line. Yani it's the opposite of max. It's a D max. What's the meaning of D max? We have only one input, but many outputs. Output 0 to output 1 or 2 or n minus 1. Okay? So it's the opposite of multiplexer. So what's the key inputs? A single input and the control line. We must use a control line. And the output, it's multiple line of outputs. Okay? So opposites of multiplexer, demultiplexer. How it works? It's the same concept but in opposite sides. يعني we use the control line, the same control line, but what? To create many outputs from one input. Many outputs from one input. Okay? So, how many demultiplexer we have? The first one, 1 to 2. يعني how many inputs we have here? How many inputs? One input. How many outputs we have? 2 outputs. Okay. We mentioned, look, the selection line or control line, it's with letter S, and the outputs, it's O0 and O1. Maybe it's not clear for you. Okay. So how we create 1 to 2 multiplexer? We use one selection line, 0, 1, and 2 outputs, O0 and O1. What's the other type of demultiplexer? 1 to 4. What's the meaning of 1 to 4? One input to create 4 output. But can we do it using one selection line? No. What do you think? We must use 2 selection line. Because one selection line, we have 2 options only. But here we have 4 options. So we need what? 2 selection line. Okay? And this is the equations of the 1 to 4 multiplexer. This is the 4 option of outputs and how we can take it out by this operation. Okay, we have example also We have the input, one input, and two control line, S0 and S1, and how we can implement the output from the one input through the what? Four outputs from one input. Okay? So, what is the application of demultiplexer? What can coming in your mind now? Okay? So, we have one input to create many outputs. So, we can use it for data distribution. يعني what's the meaning of data distribution? Send data from one source to multiple destination. يعني if I'm the lab admin here and I wanna send to all of the students Excel sheets or a program document, how I spread it from one source, from my laptop to many laptops. This is the same idea or the concept of demultiplexer. You understand what I'm speaking about? Okay. So, we will not start by decoder and encoder. We will let it for the next lecture, okay? But we have a homework, as we mentioned before, for the adder and subtractor. Please send it to me through your Google Classroom, okay? Until you have time, until when? Until today or tomorrow? Huh? Until tomorrow? Until tomorrow at 12 p.m. the last date, okay, to send the homework. What is the homework? We speak about full adder. Why we use AND gates and OR gates and XOR gate to create it. Okay? You have the truth table and you have everything. True? Okay? So we will take it before tomorrow at 12 p.m. Tamam? Okay, thank you so much for your time and for considering. Thank you.